For years, buying a new electronic device came with an invisible cost: another cable. One for your phone, another for your camera, another for your headphones, and sometimes a completely different charger for your laptop. They could all be doing the same basic jobs: moving power, transferring data, connecting one device to another, yet they often couldn't share the same connection. Then a tiny oval-shaped port started appearing everywhere. Phones, tablets, laptops, game consoles, headphones, power banks. And eventually, even the iPhone abandoned its own connector. But here's what makes USB-C fascinating. It didn't become nearly universal simply because technology companies agreed it was better. Europe changed the rules. So how did a small connector become powerful enough to influence the design of an entire global electronics industry? To understand that, we have to go back to when the idea of a universal connection was still just an idea. In the 1990s, the back of a computer could look like a control panel. There were serial ports, parallel ports, PS2 connectors, game ports, printer connections, and dedicated interfaces for keyboards, mice, and other peripherals. Each had its own physical design and its own way of communicating with the computer. The problem wasn't that every connector was badly designed. The problem was that there were too many of them. So the technology industry tried something ambitious: instead of giving every device its own connection, create one standard that could handle many different devices. That became USB, the Universal Serial Bus. The idea was beautifully simple: one common system for connecting peripherals, transferring data, and supplying power. USB-A became one of the most recognizable connectors in computing, and for a while, it looked like the industry had finally solved the fragmentation problem. Then portable electronics got smaller. USB-A was too large for compact cameras, music players, and increasingly thin mobile devices. So smaller versions appeared, including mini USB and micro USB, while printers continued using USB-B and manufacturers developed other proprietary solutions. USB had been created to reduce fragmentation. Now USB itself had multiple physical forms. Then Apple took another path. In 2012, Apple introduced Lightning for the iPhone, a small, reversible proprietary connector designed around its own ecosystem. It worked well. But it created another island in an industry that was already full of them. By the early 2010s, the dream of one universal cable seemed surprisingly far away. The industry didn't need another smaller connector. It needed a connector designed to last. And in 2014, USB Type-C arrived. At first glance, it looked almost too simple. Small. Oval. Reversible. But the shape was only the surface. Inside was a much more ambitious idea. USB-C uses a 24-contact architecture designed to support different configurations and functions, allowing the same physical connection to handle power, data, and, when supported by the hardware, other signals such as video. Even its most obvious feature, the fact that it works either way up, required careful engineering. The connector is symmetrical, while the system can detect its orientation and configure the connection appropriately. A tiny convenience on the outside. A sophisticated engineering problem underneath. And that was only the beginning. The real power of USB-C isn't its shape. It's what that shape can carry. Depending on the device and the standards it supports, a single USB-C connection can transfer data, deliver power, and carry video through technologies such as DisplayPort Alt Mode. That means one port on a modern laptop can potentially charge the computer, connect an external display, and communicate with storage or other peripherals. The port is no longer just an input. It's a gateway between different systems. Then USB power delivery changed the power equation. Earlier USB implementations were built around relatively modest power levels. Power delivery introduced something more sophisticated: communication between the power source and the device before the power level is established. The charger communicates what it can provide. The device communicates what it needs. The system negotiates a compatible level. Under USB Power Delivery 3.1, compatible USBC systems can support up to 240 watts when the charger, cable, and device all meet the necessary requirements. That's why the same basic connector can appear on tiny wireless earbuds and powerful laptops. The physical interface stays familiar while the capabilities behind it can scale dramatically. But there's an important catch. USB-C does not mean every cable is the same. Two cables can look almost identical while supporting completely different capabilities. One may be limited to basic USB 2.0 data speeds. Another may support much faster transfers. Another may handle high-power charging, while another may not support video at all. The connector tells you the shape. It doesn't tell you the entire specification. And that distinction is one of the reasons USB-C became so useful. It standardized the physical interface without forcing every device to implement exactly the same capabilities. In other words, USB-C wasn't designed to make technology identical. It was designed to give different technologies a common doorway. But if USB-C was this capable, why didn't every major company adopt it immediately? Because technology isn't driven by engineering alone. It's driven by incentives. Apple had already used USB-C in products such as the 12-inch MacBook introduced in 2015, while the iPhone continued using Lightning. From Apple's perspective, Lightning was part of a tightly controlled accessory ecosystem. USB-C was different. It was an industry standard that could be used across competing products and manufacturers. Moving the iPhone to USB-C wasn't simply a hardware decision. It also meant giving up part of the control that came with a proprietary connector. And for years, Apple had no immediate reason to make that trade. Then Europe entered the story. And this is where USB-C stopped being just an engineering story. It became an economic one. The European Union was looking at a problem that seemed small on the scale of an individual consumer but enormous when multiplied across hundreds of millions of devices. Every time a new device required a different charger, old chargers and cables could become useless or simply sit in drawers. The EU estimated that discarded and unused chargers contributed around 11,000 tons of electronic waste each year, while its common charger rules were expected to reduce unnecessary purchases and save consumers money. So in 2022, the European Union formally approved its Common Charger Directive. The important part wasn't that Europe declared USB-C the best connector in the world. It changed the rules for products sold in its market. For a wide range of covered devices, manufacturers would need to support USB-C charging when selling them in the European Union. And suddenly, manufacturers faced a different calculation. Could a global company simply build one version for Europe and another for everyone else? Technically, yes. Economically, that could be much harder. Separate hardware designs mean additional engineering, testing, manufacturing complexity, inventory, logistics, and support. Europe didn't need to control the world's electronics industry. It only needed to make ignoring its market expensive enough to reconsider. And that is the hidden power of regulation. It can change the incentives surrounding a technology without inventing the technology itself. The new requirements began applying to a broad range of covered portable devices in the EU on December 28, 2024, while laptops followed on April 28, 2026. Then came the moment that made the change impossible to ignore. In September 2023, Apple introduced the iPhone 15 with USB-C. After more than a decade, Lightning was gone from the iPhone. But here's the part that is often misunderstood. Europe did not invent USB-C. It didn't design its 24 contacts. It didn't create USB power delivery. And it didn't technically order every company on Earth to use USB-C. What Europe did was more indirect and arguably more powerful. It turned interoperability into a market requirement. A company could still prefer its own connector, but if it wanted to sell certain products in the European market, it had to meet the new rules. For a company producing millions of devices for the entire world, maintaining a special European design can be far less attractive than simply adopting one design globally. And that is how a regional regulation can create a global effect. The world didn't suddenly agree around one table. The incentives changed. Engineers had already created a flexible interface. Manufacturers had already begun adopting it. Consumers wanted fewer cables and greater compatibility. And Europe made continued fragmentation more difficult to justify. That combination is what pushed USB-C toward becoming the default physical connection for an enormous range of modern electronics. And there is one final irony. USB began with a simple promise: create a common way for different devices to communicate. But over the decades, that promise became fragmented into different connector sizes, proprietary alternatives, and incompatible ecosystems. It took roughly 3 decades for the original idea to come back around. Only this time, it was far more capable. USB-C isn't simply a smaller USB connector. It's a physical interface designed to carry power, data, and other signals through a compact connection, while allowing the technologies behind it to keep evolving. And perhaps that's the most important lesson. The real revolution wasn't that everyone finally got the same cable. It was that the connector stopped defining the device. Your phone doesn't need a completely different physical connection simply because it comes from one particular company. Your laptop doesn't need another because it belongs to another brand. The idea is much simpler. A compatible device communicates what it needs, the charger and cable provide what they are designed to deliver, and the physical connector fades into the background. That is what good engineering often looks like. Not something complicated that demands your attention. Something so well designed that you barely notice it working. So the next time you plug a USB-C cable into your phone, laptop, or headphones, remember what you're actually holding. A connector born from decades of incompatible standards, refined through engineering, adopted by an industry, resisted by powerful ecosystems, and finally accelerated by regulation. One tiny port. And one very large lesson about how technology changes. Because USB-C didn't reshape the electronics industry through engineering alone. Engineering created the possibility. The market created the momentum. And Europe changed the incentives. Sometimes, changing technology doesn't require inventing something completely new. Sometimes, it means creating an interface adaptable enough for millions of different devices to finally speak the same language.